This is the AI News Flash for June 20th, 10 a.m. UTC. First up, researchers have released a new benchmark called QMFOL for measuring the logical reasoning ability of large language models. QMFOL uses a formal logic known as monadic first-order logic to automatically generate deductive reasoning problems with finely controllable difficulty. It builds logical structures from conjunctions and disjunctions, translates them into natural language using a language model, and guarantees correctness through round-trip verification with an external prover. Across 2,880 problems and 960 configurations, the team evaluated 6 reasoning models and 2 language models and found that accuracy drops and computational overhead rises as logical complexity grows. Models also handled true labeled problems well but struggled with false or unknown ones and were sensitive to how the wording was varied. Notably, it quantifies, on the objective yardstick of formal logic, just how fragile AI reasoning becomes as complexity increases. Next, a framework called Multi-Agent Transactive Memory, or MATM, lets AI agents share their experience with one another. Until now, each agent threw away the solution path it took once it was used, but MAT stores those paths in a shared repository, so a freshly spun up agent can retrieve and reuse them. It extends the idea of retrieval augmented generation, or RAG, all the way to an agent's own execution history. The key point is that a whole population of agents can share experience without joint training or any prior coordination. In experiments on the interactive environments AlphaWorld and WebArena, retrieving past trajectories improved performance on downstream tasks and cut the number of interaction steps needed. It's proposed by Fernando Diaz and colleagues as a design pattern for reusing experience across open agent ecosystems. Third, a new study uses attention visualization to reveal how written instructions shape synthesized speech. The team adapted DAM, an attribution method from image generation, to a speech diffusion model and traced how each word in a caption conditions the audio in a text-to-speech system called CapSpeech. They extracted per-word heat maps across 25 network layers and 24 generation steps. Their findings show that style words vary less over time than content words, correlate with pitch and energy, and act most strongly in the early generation steps and the deeper layers. Attention concentration peaks at layer 17, matching the stage where style matters most. It's a fascinating result that makes visible which words a speech model reacts to, and when and in which layer. That's all for this AI News Flash.